Okay, this question was asked by one of my students in Microsoft Teams. Let me read the question. If fx is equals to 14 minus 3x divided by 4x and f inverse x is equals to 2, find the value of x and prove that f composite f inverse a is an identity function. So the question asks you to find the value of x at first, and it asks you to show that this function is an identity function f composite f inverse a. I think you may have got confused here, since you have read to show f composite f inverse x as an identity function, but the question asks you to find f composite f inverse a. So there is no such difficulty. You can simply replace this x by a, and if you replace this f composite f inverse x with f composite f inverse a, then you must get a to prove that this is an identity function. And the first part is to find the value of x by using this f inverse x equals to 2. So let's do this one. Okay, solution. Here fx is equals to 14 minus 3x divided by 4x. Okay, 14 minus 3x divided by 4x, and one more thing is given here. F inverse x is equals to 2. You need to find the value of x by using this quantity f inverse x equals to 2, and you need to show that or to prove f composite f inverse a is an identity function. You need to prove this. So let's find the value of x by using this f inverse function. For first part, let's find the inverse at first. Fx is equals to 14 minus 3x divided by 4x. 14 minus 3x divided by 4x. So to find the inverse, we need to suppose it with a. Let y is equals to fx, and y will be equals to 14 minus 3x divided by 4x. I hope you have understood the process to find the inverse function before coming to this question. So it will be y equals to 14 minus 3x by 4x. Now let's interchange the roles of x and y. Interchanging the roles of x and y. Interchanging the roles of x and y. What do we get here? X is equals to 14 minus 3y divided by 4y. Now let me cross multiply it. It will be 4xy equals to 14 minus 3y. Collect the term that has y on one side, so I'm collecting this 4xy and 3y on the left side. 3y equals to 14. Y is common here, so 4x plus 3 equals to 14, and then y is equals to 14 divided by 4x plus 3. This function, this value of y will be f inverse x. So f inverse x is equals to 14 divided by 4x plus 3. 14 divided by 4x plus 3 is the inverse function. So we need to use this value to find the value of x. Since f inverse x is given here, f inverse x is equals to 2. So let me use this to find the value of x. Since f inverse x is equals to 2, so let me replace the value here. 14 divided by 4x plus 3 equals to 2. Simplify it further, you will get 14 is equals to 2 times 4x plus 3. 14 is equals to 2 for the 8x plus 6. 14 minus 6 is equals to 8x. 14 minus 6 is 8. 8 is equals to 8x, and you will get the value of x as 1. Therefore the required value of x is 1. Therefore the value of x is 1. This is the solution for the first part, but there is one more question at the end, this tail part. Let's solve that also. Okay, the question asked me to find or to show that f composite f inverse is an identity function. So f composite f inverse A. So for second part, to show f composite f inverse A is an identity function. So let me find the composite of f and f inverse. Composite of f and f inverse. F composite f inverse x is equals to f. What is the value of f inverse x? I think we calculated earlier, and this is 14 divided by 4x plus 3. 14 divided by 4x plus 3. Let me do one more step here. Okay, this is f composite f inverse x. So I'm replacing this value f inverse x. Okay, don't get confused with the things. This f inverse x here, I'm replacing the value f inverse x. So this will be equals to f inverse x is 14 divided by 4x plus 3. I need to find the value of f 14 by 4x plus 3. Since I have fx is equals to what is given there, 14 minus 3x by 4x. It is given in the equation. You can see it from here also, 14 minus 3x by 4x. So to find f 14 by 4x plus 3, f 14 by 4x plus 3, 14 by 4x plus 3, you need to replace this x with 14 by 4x plus 3. So if you replace this x on the left side, then you need to replace this x on the right side also, both x on the right side. So I think this will be more complicated. So let's replace this. It will be 14 minus 14, this 14, I am writing this 14 minus 3 times, let me replace this x with the value 14 divided by 4x plus 3. Okay, I am replacing this x only, this x particularly, and then I need to replace it again on the denominator also. So it will be divided by 4 times this x. I need to replace this, so it will be 4 times 14 divided by 4x plus 3. Okay, do you understand this or not up to here? So now the basic simplification, we can simplify it. Let's simplify it. So it will be 14 times 4x plus 3, 14 times 4x plus 3 minus 3 times 14 divided by 4x plus 3 whole upon 4 times 14 is, let me multiply it in another step, 4 times 14 by 4x plus 3. This is the denominator part and this one is the numerator. Let me do the basic multiplication. So it will be 14 times 4x is 56, x plus 14 3s are 42 minus 3 14s are 42 divided by 4x plus 3. You may do the reciprocal here, but let me solve it as it is. So it will be equals to 4 times 14 56 whole upon 4x plus 3 denominator and the whole fraction on the numerator. This 4x plus 3 and 4x plus 3 is cancelled here. What remains? 42 and 42 also cancels. So 56x divided by 56, 56 and 56 cancels, x remains. And what we got here? F composite f inverse x is equals to x. We have got it here, but we need to show that f composite f inverse A is an identity function. As I told you earlier, if it is f composite f inverse A, then it must be A to prove that this is an identity function. And therefore f composite f inverse A is equals to A. Hence f composite f inverse is an identity function. I hope your confusion is cleared. If you have still more questions, then you can ask me later also.